LiFi, as coined by Professor Harald Haas during his TED Global talk, is bidirectional, high-speed and fully networked wireless communications, like Wi-Fi, using visible light. LiFi is a subset of visible light communications and can be a complement to RF communication, or a replacement in contexts of data broadcasting. It is wireless and uses visible light communication, that is part of the optical wireless communications technologies, which carries much more information, and has been proposed as a solution to the RF bandwidth limitations. A complete solution includes an industry-led standardization process. Technology details: it is a 5G visible light communication system that uses light from light-emitting diodes as a medium to deliver networked, mobile, high-speed communication in a similar manner as Wi-Fi. LiFi could lead to the Internet of Things, which is everything electronic being connected to the Internet, with the LED lights on the electronics being used as LiFi Internet access points. The LiFi market is projected to have a compound annual growth rate of 82% from 2013 to 2018 and to be worth over $6 billion per year by 2018. Visible light communications works by switching bulbs on and off within nanoseconds, which is too quickly to be noticed by the human eye. Although LiFi bulbs would have to be kept on to transmit data, the bulbs could be dimmed to the point that they were not visible to humans and yet still functional. The light waves cannot penetrate walls, which makes a much shorter range, though more secure from hacking, relative to Wi-Fi. Direct line of sight isn't necessary for LiFi to transmit a signal. Light reflected off the walls can achieve 17 bits. LiFi has the advantage of being useful in electromagnetic sensitive areas such as in aircraft cabins, hospitals and nuclear power plants without causing electromagnetic interference. Both Wi-Fi and LiFi transmit data over the electromagnetic spectrum, but whereas Wi-Fi utilizes radio waves, LiFi uses visible light. While the U.S. Federal Communications Commission has warned of a potential spectrum crisis because Wi-Fi is close to full capacity, LiFi has almost no limitations on capacity. The visible light spectrum is 10,000 times larger than the entire radio frequency spectrum. Researchers have reached data rates of over 10 Gbps, which is more than 250 times faster than superfast broadband. LiFi is expected to be 10 times cheaper than Wi-Fi. Short range, low reliability and high installation costs are the potential downsides. Pure LiFi demonstrated the first commercially available LiFi system, the LiFirst, at the 2014 Mobile World Congress in Barcelona. History. Professor Harald Haas, from the University of Edinburgh in the UK, is widely recognised as the original founder of LiFi. He coined the term LiFi and is chair of mobile communications at the University of Edinburgh and co-founder of Pure LiFi. The general term visible light communication includes any use of the visible light portion of the electromagnetic spectrum to transmit information. The D-Light project at Edinburgh's Institute for Digital Communications was funded from January 2010 to January 2012. Haas promoted this technology in his 2011 TED Global talk and helped start a company to market it. Pure LiFi, formerly Pure VLC, is an original equipment manufacturer firm set up to commercialize LiFi products for integration with existing LED lighting systems. In October 2011, companies and industry groups formed the LiFi Consortium, to promote high-speed optical wireless systems and to overcome the limited amount of radio-based wireless spectrum available by exploiting a completely different part of the electromagnetic spectrum. A number of companies offer unidirectional VLC products, which is not the same as LiFi. VLC technology was exhibited in 2012 using LiFi. By August 2013, data rates of over 1.6 Gbps were demonstrated over a single color LED. In September 2013, a press release said that LiFi, or VLC systems in general, do not require line-of-sight conditions. In October 2013, it was reported Chinese manufacturers were working on LiFi development kits. In April 2014, the Russian company Stinskoman announced the development of a LiFi wireless local network called Beamcaster. Their current module transfers data at 1.25 GB per second but foresee boosting speeds up to 5 GB per second in the near future. Standards, like Wi-Fi, Li-Fi is wireless and uses similar 802.11 protocols. But it uses visible light communication, which is much wider bandwidth. One part of VLC is modeled after communication protocols established by the IEEE 802 workgroup. However, the IEEE 802.15.7 standard is out of date. Specifically, the standard fails to consider the latest technological developments in the field of optical wireless communications, specifically with the introduction of optical orthogonal frequency division multiplexing modulation methods which have been optimized for data rates, multiple access and energy efficiency. The introduction of OOFDM means that a new drive for standardization of optical wireless communications is required. Nonetheless, the IEEE 802.15.7 standard defines the physical layer and media access control layer. The standard is able to deliver enough data rates to transmit audio, video and multimedia services. It takes into account optical transmission mobility, its compatibility with artificial lighting present in infrastructures, and the interference which may be generated by ambient lighting. The MAC layer permits using the link with the other layers as with the TCP/IP protocol. The standard defines 3 PHY layers with different rates. The PHYI was established for outdoor application and works from 11.67 kbits to 267.6 kbits. The PHY2 layer permits reaching data rates from 1.25 Mbps to 96 Mbps. The PHY3 is used for many emission sources with a particular modulation method called color shift keying. PHY3 can deliver rates from 12 Mbps to 96 Mbps. The modulation formats recognized for PHYI and PHY2 are in off-keying and variable pulse position modulation. The Manchester coding used for the PHYI and PHY2 layers includes the clock inside the transmitted data by representing a logic 0 with an OOK symbol 01, and a logic 1 with an OOK symbol 10, all with a DC component. The DC component avoids light extinction in case of an extended run of logic zeros. The first VLC smartphone prototype was presented at the Consumer Electronics Show in Las Vegas from January 7 to Euro 10 in 2014. The phone uses Sun Partners WZIPS Connect, a technique that converts light waves into usable energy, making the phone capable of receiving and decoding signals without drawing on its battery. A clear thin layer of crystal glass can be added to small screens like watches and smartphones that make them solar-powered. Smartphones could gain 15% more battery life during a typical day. This first smartphones using this technology should arrive in 2015. This screen can also receive VLC signals as well as the smartphone camera. The cost of these screens per smartphone is between $2 and $3, much cheaper than most new technology. Philips Lighting Company has developed a VLC system for shoppers at stores. They have to download an app on their smartphone and then their smartphone works with the LEDs in the store. The LEDs can pinpoint where they are located in the store and give them corresponding coupons and information based on which aisle they are on and what they are looking at. See also, references.